Alright, so today we are talking about irregular polygons. Irregular polygons. Now I know that seems odd, but if you recall, irregular polygons are just not regular. And what's a regular polygon? What is a regular polygon? All equal sides, right? All equal sides, all equal angles. So irregular, you presume, means what? Not equal sides, not equal angles. That's simple. Now, we've been dealing with a lot of irregular polygons. More polygons are irregular than they are regular.
I have a question?
Yes.
What do you like better? Irregular or regular polygons?
Oh, irregular, hands down. Now, the thing is, we are going to deal with polygons. Christian, please stop talking. Kieran, please stop talking. So, we're going to deal with polygons that look like this. What kind of a polygon is this?
Irregular.
It's a what?
Irregular polygon.
Well, it is irregular. But what specific type of polygon? Chandler.
Hexagon.
It's a hexagon. Yes, thank you, Emily. It is a hexagon. Now, it's a hexagon not because it looks like one, but because it has what? 1, 2, 3, 4, 5, 6 sides.
6 different sides.
Now, we're going to be dealing today with area and perimeter of irregular polygons. All right, guys over here. Please stop talking. Talk if you have questions about this, if you're answering questions, but that's it. So, I'm going to put some numbers up here. I'm going to say this, I don't know, 10, 6, 3, 8, something like that.
And I think the other one's 4.
Now, Connor states one of these others is 4. Now, I have two sides I haven't labeled, the bottom one or the side one.
And the other one is 7.
Okay, so you're saying one of these is 7.
Yes.
You're saying, I presume this is 7?
That's 7 and then that's 3.
This is 4. What do you guys think? Do you agree?
How does he know that?
Well, I don't know. How does he know?
It would be 7 because that's 3. So 8 minus 3.
Okay, so you're saying this would not be 7.
No, it's 5.
Kieran.
Oh yeah, he's right. It's supposed to be 5.
Okay, so what Samara and Emily are saying is this should not be 7 because what they are noticing, I know. They're noticing that this from here all the way down to here is 8. Now on the other side, here to here should be 8. And you all picked up on the fact very quickly that this side and this side together are going to form that entire distance, right? So if one of them is 3, the other one has to be 5 so that together they can make 8. Now does our logic saying this side is 4, is that sound? Yes. Absolutely. Because this bottom side is 10. So here to here is 10. We have 6 of that taken up here. So what else do we need to get it to 10? 4 more. So yeah, this side is, in fact, 4. So we can find missing sides of irregular polygons simply through asking what is it on the other end of this. Now we can find the perimeter really easily, right? Add up all the sides, find the perimeter. 6 plus 8 plus 10 plus 3 plus 4 plus 5. I'm not actually going to add those up. That's not the point of this. I wanted to show you how we find those sides. Now, what can be a little bit more difficult is the area. Because do you think we can just do base times height here? No. One moment. Do you think... Oh, okay. You sure?
But you probably can. They're both the same size.
You just cut the shape in half.
Okay, so do you think there's a set area formula for a shape like this?
Yes.
Well, Christian, what do you think?
I think if you draw the, you know how the 8 on both sides, you cut that little square off?
Okay.
You go straight down that line.
Okay, so you're saying not necessarily we have a formula, but you're saying what you're looking at is you're looking at saying, what if we treat this as 2 different shapes?
Yeah, it's like a triangle.
Christian, that is fantastic. You're going to get a point for that. Remind me of that later in the end. That is fantastic. This is exactly what we want to do. When we have an irregular polygon, we want to separate it into shapes we're more comfortable with. We know how to find the area of rectangles and squares. squares, right? That's pretty straightforward. How do you find the area of a rectangle or a square? Base times height. But what happens is we had a weird L-shaped hexagon. There's not an area formula for that. It doesn't exist because it's an irregular polygon. There's not area formulas for irregular polygons. But if we separate this shape, this irregular hexagon, into two shapes we are comfortable with, a rectangle and a rectangle, we're in a much better place. We can find the area of these separately and add them together. Kent?
Would you do 4
Times 2.
Yeah, absolutely. So Kent is looking at this, and he's thinking, what are the dimensions of just this box? What are the dimensions of just that box? 4 and 3. We notice it is 3 on this side. It is 4 on this side. So we're going to have 4 times 3, and we're going to get 12 as the area of that little box. Now, what is the area of our larger box? Chandler, what is the sides of our larger box, the dimensions of our larger rectangle? 8 and 10? What do you all think?
8 and 6.
Not quite.
Yep.
Connor, can you agree with Christian's answer? Yes. 8 and 6, because we're just looking at this rectangle. We see it has 8 here, and its shorter side is 6. If we look at the 10, that's all the way across, right? So we are going to be doing 8 times 6. 8 times 6 to get 48. We can add them together, 48 plus 12, and we get 60 units, whatever it is. 60 units squared, because we're dealing with area. So when we have irregular polygons like this, we are going to separate them into shapes we know. We are not going to do a worksheet, but I am going to have some practice problems. All right. Now, I'm going to... What? Well, I'm going to put another problem up here right now, yes. So I'm going to put a problem up here like this.
Oh, yeah.
First off, what kind of a shape is this?
Hexagon.
Not hexagon.
Octagon.
Yeah, octagon, right? It is an octagon. It has 8 sides. So let me label some stuff here. I'm going to say 3 and 3. 16. 9. 9. And 4. And 4. So here's the question. Do we have any missing sides here?
Yes.
Carson, what is it?
Yes, and it's 10.
It's 10. It's that middle side right there. We didn't know this off automatically, but Carson says it's 10. Now, how did Carson know it was 10? Zoe, how did he know it? Okay, Christian, how did he know it?
16 minus 6.
16,
Yeah.
all the way across, and then each of these kind of tower-looking parts of the shape, right? These make up 3 of this distance, 3 of this distance, so the other part of the 16 must be made up by that area in between. 3 plus 3 is 6, and that would mean we would still need to make up another 10. So that's how we know that side is 10, absolutely. Now we want to separate this into smaller shapes to find the area. So where do you think we might make some lines?
Right there, cut the towers off basically.
So you're saying cut the towers off of this.
Yeah.
Line like this, line like this?
Yep.
Okay. Emily. Okay, so Emily's saying maybe, we could cut it off like this. We could do this, but we could also do straight down, right? It doesn't matter which one we're doing. We can do any of them. Or, get this, we can go down and we can go over.
How about no?
Wow! Let's do that one. That one looks fun. That one looks like the most fun. I know you all disagree, but I think it's most fun. Okay, so what I'm going to do is I'm going to call on someone, and I want you to tell me the dimensions of one of these boxes. So Carson, you got your hand up. What is the dimensions of this box? This box, yeah. 9 and 3. 9 tall, 3 wide. 9 times 3. So what's its area going to be? 27. All right. Now, Would the other one be 27 is the question. What do you all think? If this is 27, would one of the other boxes
If
be
you draw
27?
a straight line down, it would be 27.
Yeah.
But then again, it's not a whole line, so you have to go by the 4 and then
Yes.
3.
So
12.
what Christian is saying in an answer to that question is if we would have drawn our line straight down, yeah, the other one would have been 27. We didn't do it that way, so it's going to be a little different, but ultimately we'll end up with the same answer no matter how we divide this. So Max, can you tell me what are the dimensions of this shape?
What did you just say?
What are the dimensions of this shape? What do you think, Max? All right, Max, call on somebody else. Carson, you got this one too.
13 times 5.
13 and 5. Where are you getting the 13 and 5 from?
Well, 3 minus 16 is 13.
Okay, so you're saying 3 of this distance is cut off here, so that must be 13 across, absolutely. And then what'd you say its height was?
9 minus 4.
9 minus the 4 up here, so it must be 5. Now 13 times 5 is 65, if I'm correct?
Yes.
All right, 65. So finally, Samira, what is the dimensions of our top box?
I already told you
Do you mean like the side? Like
What are our dimensions of this box?
3, 4, and
4 times 3.
yeah, oh, 4.
Yeah, so as Kent and Samara are saying, it is just 4 and 3, right? All right, 4 and 3 is going to give us 12. So in total, Connor, 104. 12 plus 65. All right, quiet down, everyone. Everyone. Him. Please. All together, these areas are going to add to 104 if Connor is to be trusted. Units squared. All right. That is irregular polygons. We're going to do a couple more examples of this.